Hello everyone, in this video I'm going to show you how to use LSTM, long-term, short-term memory, and GRU for weather forecasting, and I'm going to keep it simple so you can track what's going on and understand what's going on in my code. Here in Kaggle website you can download, I will put the link of this in the description, and also you can download this one. After downloading you have to copy that in the directory of your Jupyter notebook. And then you can use import pandas as P for importing pandas. Then you can read that the file here. The name of this file is CT_temperature.csv is a CSV file. So you can read this file, and if you just simply write df, you can see that here is the data from 1995 to 2013, and average temperature for each day for different cities. And what I'm going to do here, I just want to filter this one, the main CSV for the year 1996. Then I'm going to show you. Just keep in mind that what I'm doing here is is not the most efficient way, but I didn't use ChatGPT or my cheat sheet. I just wanted to remember what I know about pandas. So you may find a better solution to filter the main CSV, but this is mine, and I think it's one of the easiest ways. Okay, you can see that now the year is just 1996, and I'm gonna ignore the columns except the city and average temperature column. So I'm filtering here, and I'm gonna pick the one of the cities. Here I'm gonna pick Algiers. I'm not sure about the pronunciation. It's a city in Algeria, and I'm gonna call it new data frame, and you can see that here is my new data frame, but the index here starts from 365 to 730. I'm going to change this, but before that I'm going to change the temperature from Fahrenheit to Celsius degree with this formula. If we multiply 5 divided by 9 by Fahrenheit minus 32, we will get the temperature, which is in Celsius, and we want to apply it to all columns. And after doing that, we're just taking this column and applying this function to that. And after doing that, we can see that the temperature is turned into Celsius degrees. And I'm also rounding this one, ignoring all decimals except one of them. You can see here is data is cleaner. And also I'm going to reset the index, so the index will be started from 0 to 365, and I'm going to drop this column because I no longer need that, and this is my new data frame. So we are good to go, and we can start coding our LSTM for weather forecast. But first of all, we have to know that so here are our temperatures. First of all, we have to know that if we show if you want to use a values attribute in pandas, we can see that here in an array, here are all the temperatures, okay? And the type of the temperatures are numpy, and here is a shape. And we want to reshape that to have a column vector because we want to normalize the data, and for normalizing the data in Python using a scalar library, I'm going to show you in a few moments that you will need a vector column. So here, what I did here is just turning this one to a column vector, and I plotted to show you that how temperature changes. And you can see that maybe here we have an outlier, but just let's ignore that one. And this is before pre-processing. It means that I didn't apply what you may call it normalizing here yet, but here I just from scalar and pre-processing library I imported min-max scalar. And what is min-max scalar? Let me show you here. Min-max scalar. With this formula, this is my data in each time series, and I want to deduct that from the minimum value, and also divide the total amount by x max minus x mean. X max is the maximum value in my data. So here, I just use the min-max scalar that will do the same formula and will fit and transform on my data. So here I called min-max scalar, and this is my scale temperature. And I'm just plotting. You can see that the temperature is within the range of 0 to 1. This is the typical behavior of min-max. You can also change the range from 0 to 1 to anything else. But by default, after using min-max scaler, you will have data within 0 and 1, and this is much better for your neural network because it could converge faster. You can also avoid vanishing and exploding gradients problem. And here I just showed that why we use flatten, and you see that the original data is without, is 1D, one-dimensional array, and after reshaping it's 2-dimensional, and I just use flatten. Flatten makes my data 1-dimensional again. Okay, so for using the scalar, my temperature should be column vector and also 2-dimensional array, and after applying the normalization, I'm just turning my data back to its 1-dimensional shape as before. Okay, here I'm creating the sequences. What do I mean by sequences? Let me just show you here how LSTM works. Assume that, let me change this one to Markdown. Okay, assume that this one is my data. I have 1, 2, 3, 4, 5, 6, and so if I assume that my sequence length is something like 2, what do I mean by that? I mean that for sample 1, my x should be 1 and 2, and y should be 3, the next one. For sample 2, x should be 2 and 3, and y should be 4. And let me copy this one. For sample 3, this one should be 3 and 4. The next one, the predicted one, should be 5. And this one should be 6. And this one should be 4 and 5. Okay? So I will give this one to the LSTM, and I will say that this is my sequence, and I can change the length of sequence. But if we have n data, n is the number of the data. Here we have 6, so n is 6. And we have L sequence length. Here L is 2. We will have n minus L, which is 6 minus 2 samples. And as you can see here, we have 4 samples. Okay, so this is a working principle of the LSTM and also GRU. What we are doing here, we say, okay, n is the length of our data, and data is the temperature, scale temperature, and we say that x and y will be our training and also target or label or output data set. So here we say that we wanna make a loop to create this data, something like this. X will be 1 and 2, 2 and 3, 3 and 4, and 4 and 5. But for 1 and 2, we will say that the output is 3. For 2 and 3 is 4, and so on. And you see that here is the output of this code. And what we make here as x and y is the list, but we have to change that to a NumPy array. And here I changed them to NumPy array. And here is the full code. And you may understand it better right now. We are just importing in this block. We are just importing the libraries, NumPy, Pandas, TensorFlow, and this one for plotting, and this one for LSTM and dense layer, and this one is for normalization, and this one is our data. We are normalizing the data here, and we chose 2 as our sequence length, and here we are creating the sequences. Here we are creating the sequences and changing the, somehow creating the training data set and also changing them to NumPy array from the list. Here we initialize them as list, and we have to reshape the x in a way that we have something like this: samples, time steps, features. Time steps are determined by the sequence length. So in each sequence, here, for example, let me say, let me use here. Here, this one is our sequence. We have 2 time steps, and in each time step we have 1 feature, and we also have 1 output. So here in this code, we have samples, x.shape. The first part of shape is the number of samples, and the time step is sequence length, and features, we have 1 features here, the temperature, the average temperature. Here we just split the data to training and test data set, and we will also have validation data set. I will show you. So 80% goes to training, 20% goes to test. And here we define the model. We have a input layer. We have LSTM layer with 50 neurons. And here shape is sequence and sequence length, which is time step and the feature. And here we use Adam optimizer and MSE loss, and we train the data by model.feed with 100 epochs, and 10%, the last 10% of the data is used for test, and we predict the X test by the trained model, and we rescale it, we inverse the predicted amount because we use the scaled X, so we have to inverse that, and we plot it. That's it. And after training, you can see that here is the result. This one is the true temperature, and this one is the predicted temperature. If you have any questions, comment below. I will answer them. And also, if you think something is wrong, please let me know. And if you need these codes, I will provide if you ask.